Hey folks, it's homework help time, and this problem in particular can cause fits in the inverse function section. I want you to always put an alarm on when you see even roots, like a square root, a fourth root, a sixth root. You know what I mean by even roots, because there's an implied 2 here. Or you see squares in your function. So you have an x squared, or an x plus 1 squared, or an x squared minus 5, or even an x to the 4th. So even exponents and even roots, warning, because your domain and range can turn into issues. Okay, so we're working with f of x equals x minus 3 squared. Now, you know the steps for calculating an inverse. At least I hope you know the steps for calculating an inverse. If not, we're going to do it together. So the first one is to rename this in equation form. In other words, call it y is equal to x minus 3 squared, where x is less than or equal to 3. Now, what's up with this x less than or equal to 3 situation? Well, if we graph very quickly up at the top here, if I graph x minus 3 squared, now here's what we're supposed to know at this point. This is a parabola because it's squared, moved right 3 units. So I move it to the right 3. Now, that's what that function looks like. It's not pretty, but that's what it looks like if I ignore the x is less than or equal to 3 rule. But guess what? Because that says x is less than or equal to 3, I'm not allowed to graph this thing any larger than 3. So I'm going to erase, watch me erase, every part of the graph that's bigger than 3. Also erase part of my line. So basically, this is what this function looks like. Now that passes the horizontal line test, right? So now it has an inverse. The way I had it before, it didn't have an inverse at all. Now let's go ahead and do something, because it says use interval notation to give the domain and the range. So the domain, just look at the graph. The domain of this function is going to be, remember that's left to right, so negative infinity, and then it stops at x equals 3. Domain is x values. The range of the original function, that's low to high, 0 is the lowest point on this graph, and it goes up to infinity. And then we have a bracket around the 3 and a bracket around the 0. Okay, now why am I making a big deal about this domain and range business when I didn't in other problems? Because it asks about the domain and range, and you really have to be careful when you're not looking at negative infinity to infinity, when you have a restriction on your problem, okay? All right, so this is what we're looking at, original function. Now we're switching the x and the y next, right? We did the first step, we wrote it as an equation, now I'm switching. X is equal to y minus 3 squared. Okay, I'm going to ignore this x is less than or 3 for now and just do the math. Trying to solve for this y, I've got to get rid of this square, so I'm going to take the square root of both sides. Okay, I take the square root of this side and the square root of this side. It's so easy to forget that when you take the square root, when you use the square root as a tool on your own, you must put a plus or minus in front of one of the sides, preferably the side that you are not, the other side, the one with not your variable you're trying to solve for, okay? So let's write what we have. So right now we have plus or minus the square root of x is equal to this, well, the square root's gone, right? Let me go back and fix that. Got a little ahead of myself there. Okay, this square root and this square cancel. So we just have y minus 3. Now it turns out in this particular situation, both of these things do not apply. Okay, so is it the plus the square root of x, or is it the negative square root of x side? How do we know? Okay, now remember we switched the x and y values. Okay, so once you switch the x and y values, the domain turns into the range, and the range turns into the domain. But that still doesn't really tell you which one of these two to pick. Now, the safest thing I can tell you, we could dig deeper into this, but I think what you really want to know here is it's the positive square root of x when you're talking about the right side of the parabola, and it's the negative square root of x when you're talking about the left side of the parabola. This might be the trickiest problem in the bunch, okay? So that gives you negative, all right, negative square root of x, okay, so we are ignoring the plus because that would have been if we were working with the right side, is equal to y minus 3. I'm trying to get this y by itself, so I'm going to add 3 to both sides of this equation, and then that's going to give me my inverse, which is 3 minus the square root of x is equal to y. In function form, that's f inverse of x. They give you that notation, and you type in 3 minus the square root of x. That's your inverse, okay? So it says find an equation, but there's more to this, because when you find the equation, they want to know the domain, okay? Here in the original, they said x is less than 3. Well, what does x need to be here? Well, remember, when you find the inverse, very important here, the domain turns into the range, and the range turns into the domain. Okay, so this now is our domain in interval notation, because that's just the way I wrote it, but another way to write that would be x is greater than or equal to 0. So you've got to easily in this class be able to convert from from interval notation to inequality notation, that's what this is called, or inequality notation to interval notation, okay? And again, I could have wrote it up here. That just would have meant y is greater than or equal to 0, okay? And this would have meant x is less than or equal to 3. But interval notation is just a little bit easier to use, I think. But they ask for it in the homework like this. Okay, that's just part A. And then part B, they want you to graph. Now, we've already graphed the original function. Remember, it's the parabola, moved right 3, but only graph for x is less than or equal to 3. Now, here's what I want you to keep in mind. And I can graph it again. It's still not going to be pretty, even if I make it bigger. 2, 3. Remember the parabola, and it's just the left side. Okay? Now, you could look at this and graph. Now, one way to think about this is a square root graph reflected in the x-axis. Why? Because of that negative in front of it, and then it's moved up 3. Now, why would you say that? Because I could put that plus 3 in the back. You could write it as negative square root of x plus 3. That would work. So you could graph that if you needed to. Another way you can handle it is you can always think about these graphs as a reflection through the line y equals x. And if you imagine reflecting this through, then if this is over to the right 3, then we're going to be talking about the other graph is going to be up here at 3. Let me do this in a different color. Let's do pink. Okay, at 3. And if you reflect through, okay, it's going to look similar to that. Now, does that match my graph? Well, yeah, that's a square root graph, up 3 and flipped upside down. But you're just matching, and I know you can handle that. Okay? Then finally, use interval notation to give the domain and the range of f and f inverse. Now, I've missed this problem before because I wasn't paying attention. They want the domain and the range of f and f inverse. So you've got 4 questions to answer. So the domain of f in this case, remember, I wrote it right here, negative infinity to 3, because they only wanted us to graph for x is less than or equal to 3. That is your domain. The range is low to high. Now, that took me graphing it to truly see that. That is 0 to infinity. Again, it really took the graph for me to see that. Now, I'm going to change colors on you again just because I like to. Right? Okay, so now let's do the domain of f inverse. Now, we haven't calculated that, but we don't have to. Remember, the domain and range of f inverse switch from the original function. So f inverse is going to be the range, 0 to infinity. Okay, and then the range of f inverse, of course, is going to be the domain, negative infinity to 3. And when you're matching your graphs, make sure that's true also. Okay, there's another one for you. Hope that helps. I'm going to do one more in a separate video for this homework because I know this homework can be a booger.